Okay, this is question 20, given that the expansion of each term can be written as a polynomial in x of degree 100, where the coefficients are a0, a1, a2 up to a100. We also find the absolute value for this expression. This question looks scary, and there are a few ways to deal with that. One of the possible ways is use a binomial theorem to expand each of this, but it is a little bit tedious. Now we can actually get the answer quite easily by saying that this is px. So we let this is px, it can be written in two different ways. Now we can consider p0. We sub x as 0. So this will be equals to 1, this is equals to 1, and each of these is actually equals 1. And we have a total of 100. So this is 100. P0 is equals to 100 using the first row. Using the second row, P0 will be equals to A0. So we know that A0 is equals to 100. How about P of 1 over 3? P of 1 over 3, from the first row, it is equals to 0, 0. Every term is 0, so it is a 0. And from the second row, P1 over 3 is equals to A0 plus A1, 1 over 3, plus A2, 1 over 3 square, and all the way to A100, 1 over 300. And note that all this term is exactly equal to this value here. And therefore, we know that A1 over 3 plus A2 over 3 square all the way to A100 over 3 to the power of 100 is equal to a negative A0 and is equal to a negative 100. And therefore the answer is equal to 100. So 100 is the answer for question 20.